Okay, we're back. Math 200, Chapter 5, 5.7. We're looking at page 15 in the note packet. And we're doing perfect square trinomial factoring, which is actually easier factoring. This is an easier, you don't have to worry about AC method or, writing a list of suspects or anything like that. When they tell you it's a perfect square trinomial, that means it's the same binomial times the same binomial. So all you have to do is square root. You do the square root of x squared, that's x. The square root of 36, that's 6. And you've got your answers. The only thing is you have to see if it's plus plus or minus plus. If it's plus plus, they're both pluses. X plus 6, x plus 6. And if that was a minus plus, then they'd be both minuses. So that's what's happening here. Let's look at this one. It's just the square root of 16x squared, which is 4x, and the square root of y squared, which is y. And so you just do two parentheses, two sets of parentheses for the binomials. You put in 4x and 4x, y. And in this case, because that's a minus, it's got to be minus, minus. Done. So this square root of 4m to the 4th is 2m squared. The square root of 1 is 1. I must have written that down wrong. I did. That's got to be a plus, otherwise it wouldn't be factorable. That's 1. And so then we have 2m squared, 2m squared, and minus minus because of that minus sign there. 1. And that's it. The middle term will check out. Look, if we do 6x and 6x, that's 12x. Negative 4xy, negative 4xy, that's negative 8xy. Negative 2m squared, negative 2m squared, that's negative 4m squared. And so it doesn't matter if they're bigger numbers or smaller numbers. This was pretty easy. This one's bigger numbers, but it doesn't really make it too much harder. We're just going to take the square root of that, get 5x. And then the square root of that, and get 3. And a couple of pluses, and we're done. So the next thing we're going to look at is factoring the difference of two perfect squares. The difference of two perfect squares, which is also pretty easy. When we were multiplying binomials times binomials, we talked a little bit about conjugates. Well, when we're factoring, it factors out to be a conjugate. So x squared minus 9 and 4x squared minus 1. It's just like how we did it before. You take the square root of the first thing, the square root of the last thing, and you write down those. The only difference is this is x, 3, 3. Since there is no middle term, these have to be conjugates. So that's going to be a plus, and that's going to be a minus. Square root of 4x squared is 2x. Square root of 1 is 1. So you have to look for these things. A perfect square minus a perfect square. 1 is kind of a tricky one because you don't really look at 1 as a perfect square. But it is. All right? So then we're on to page 16. Page 16, they have us bumping into factoring the sum of two perfect cubes and the difference of two perfect cubes. So let's take a look at that. We have to write it as a perfect cube. That's the first thing. And then this is just a memorized process. Just a memorized process. So it's always a binomial times a trinomial. And when it's a plus, it's a plus sandwich with minus innards. Like the pluses are the bread and the minuses are the innards. All right? So remember this sequence. A binomial times a trinomial, and if there's a plus there, it's plus minus plus. All right? Now we just fill in the blanks. This always goes here. This always goes here. For this one, the first term in the trinomial, it's whatever this is times itself. So x times x is x squared. The last one is whatever this is times itself. 1 times 1 is 1. And the middle one are those times each other. So 1x, just x. And we factored. That's it. It's kind of a memorized pattern. You have a memorized pattern of factoring. So let's look at more problems like that. Factoring the sum of two perfect cubes or the difference of two perfect cubes. So when we look at the difference of two perfect cubes, on the next one, we got y cubed minus 64. And let's see here, we got 8t to the third plus s to the sixth. And we've got x cubed y 6 plus s. Oh, wait. X3 y 6, 27. So 27. Z3. Okay. So look, this one, let's break it down into perfect cubes. So that's a little tougher with the 64. And you can use your calculator to help you with that. You take 64 to the, and then do a parenthesis, 1 divided by 3 power. The 1/3 power is the cube root of 64. So if you type this into your calculator and hit enter, calculator, and hit enter, it'll kick out the 4 for you. 4 times 4 is 16 times 4 is 64. All right, so it's a minus. So again, it's just kind of a memorized pattern when you're doing these factoring. This time it's minus plus plus. So like an open face sandwich. There's always two pluses and a minus every time you do these. Again, same pattern as before. This y goes right here. That 4 goes right there. This thing is whatever this is times itself. So y squared. Last one is whatever this is times itself. 16. And the middle thing is those times each other. And you're done. Factored. So the hardest part of these is getting this busted down into, like, this is 2t to the third. 2t times 2t times 2t is 8t to the third. Minus, this is s squared to the third. Because remember, when you have a power raised to a power, you multiply. So a 2 goes there times a 3 there. We always want them as perfect cubes. Now we do our 2 empty sets of parentheses. It's a minus again, so that's minus plus plus. And now you just insert. It's just fill in the blanks. We got 2t here. We got s squared there. This first term of the trinomial is always this thing times itself. So 2t times 2t, 4t squared. This is always this thing times itself. S squared is s4. It's not a 14, it's just a 4, s to the fourth. And the middle thing is those times each other. So 2ts squared. All right. Number 4. We're going to do xy squared to the third plus 3z to the third. And then when we look at that, it's a plus, so plus minus plus, and xy squared, 3z, x squared y4, 9z squared, and those times each other, 3z x y squared. Okay, let me see it, make sure you can see that. On the other side, yep, we just made it. All right. Number 5 and number 6. Look like this. 5x cubed minus 2x squared minus 36x plus 72. And 6. 2a cubed minus 90 minus 18a plus 10a squared. All right. And that finishes off that page. Still doing good. All right. So, factor by grouping, greatest common factor. X squared comes out. X squared there. X squared there. And so that's x minus 2, and then factor out a negative 36, 36, negative 36, that's x minus 2. And we factor an x minus 2 out front, and we're left with an x squared minus, oh wait, did I do that right? 2, and then that's it. Oh no, x, yeah, x minus 2, x squared minus 36. I don't know what I was thinking, I should have shown my work. X minus 2, x minus 2. Okay, but wait, there's more. We have x minus 2. And then this is x plus minus 6 and 6. This one, do we have to do a little rearranging, huh? A little rearranging? Let's rearrange. So we have 2a to the third. Let's put the plus 10a squared up front. Minus 18a minus 90. So we rearranged it. We pumped this there and put that last. All right. Factor out a 2a squared. Oh, wait. Before we start, whoa, hold up there, Tex. Let's factor out a 2 out of everything. 2 out of everything. Divided by 2, divided by 2, divided by 2, divided by 2. A cubed plus 5a squared minus 9a minus 45. Much better. Now let's factor by grouping. We'll pull the a squared out and get an a plus 5. We'll pull a negative 9 out and get an a plus 5. We'll pull an a plus 5 out. So now we have the 2 kicker out front. We have an a plus 5. And then what's left is a squared minus 9. But wait, there's more. 2 times a plus 5. That's the difference of two perfect squares. A plus minus 3 and 3. Whew, that was a toughie. So that's it for 5-7.